Oh, that's ground. We have nothing. That's why. Holy. Well, good morning, Internet. I am Keeney, and today in the garage, life brings us the 1955 Chevrolet 150, spelled out apparently ONE-FIFTY is the model name of this old girl. The story goes, the car was purchased some time ago. The car had some upgrades. It got the small block 350. It got the 700 R4 trans. It got the 12 volt system update. I think these may have been a 6 volt. Back then, I don't really know. I did not look that up. But she's running a 12 volt system with a little bit more modern powertrain. And the complaint is, the story goes, the air conditioner does not work. Apparently, there are potentially two problems going on with the air conditioner. Problem one is the blower will only operate on low, and the blower apparently has 24 volts going to her. We don't know where that 24 volts is coming from on a system that I think was a 6 volt, has become a 12 volt, and yeah. The HVAC blower was previously wired in by somebody else who is apparently no longer around after that thing that went around the world and caused so much havoc. So we can't go back to that individual because they don't exist anymore, which is unfortunate. And apparently all of the blower motor wiring is the same color. I have not looked yet, but apparently they're all red wires. Likewise, there is no power going to the AC clutch, but our priority in order is to figure out the blower motor issue first, and then move, if we have time left, move to the AC clutch. But that's what I got. That's what I know so far. I don't know if some of the factory wiring diagrams are going to be of much use to us. Supposedly, the blower was wired in such that the factory blower switch is still functional, so it's supposed to be running through that switch. And I do have a resource, a couple, two or three different like online resources where we can download some of the ancient stuff. But again, since we know she's been mildly updated, I don't know how much of that's going to apply. So we might just be doing a bit of reverse engineering and trying to figure out what was going on with there. But that's what I got. It does apparently have a battery drain issue too. If you leave the battery cable connected more than 3 days or something, it won't want to restart, but they're not worried about that at the moment. He just pulls the negative battery cable off. But that's what we got. Let's go on a field trip. We got the small blocks. We got a couple upgrades. The EverStart 12 volt battery. Inside, I think this door's open. She's still going through some resto. So like there's no door panels on her. Dash looks mostly factory. We've got a semi truck turn signal over there. We've got a digital tachometer. We've got the GPS for vehicle speed because the speedo cable does not work. She's got the Hurst shifter, and as far as I can tell, that right there is going to be our blower controls. And I can see we've got some purple wire running down and across. and what looks like, if I get down under here, what looks like some non-55 based wiring and an open connector. That is what I know about this vehicle. Still got a little bit of work to do on the inside to get her spun up, but overall, she's in pretty good shape. She's got a little bit of surface rust underneath, but nothing that seems to have been penetrated. That's what we got. This is where today is going to lead us off. I suppose I'm just going to get the scope out and start plugging on wires and see what voltages show up underneath this dash and go from there. Here's the most basic of what I think I have identified. This connector that you can't see, this connector here goes directly into the blower motor up there. And I think we're just going to start on this end. I'm going to do some resistance checks, probably jump power to this and make sure that blower works. I don't know what this dude goes to, and if we, I don't know if I can get the camera up in here, but up under here further, right there, this is on the way, there's a blower motor connector that matches that, but that one comes from like some insulation. I can only see like 2 or 3 inches of wire, and then it gets buried somewhere in the dash. I don't know where that's coming from or where she's going, and we will keep that in mind. There's some twisted pair wires here. I don't know where those go to. And if we kind of come through the firewall that you probably can't see very well, looks like, get the light up in there. So there's a wire harness and a twisted pair that come through the firewall. And I don't see any rub spots. I did move them around. That wire harness is what comes to right there and has all those modern color wires coming out of it. That is what I know at the moment. I do believe I'm going to start with this connector on the blower motor. We'll just check some resistance, see if it actually takes power or some current measurements to make sure the blower looks okay. A little difficult to get this all in the same shot, but we will give her our best go. Looks like 2.5 ohms. I think I saw 2.5 in there. My motorcycle's going by. Now we're at 3, 2, 2.5. She's hovering around the 2.5 mark. I think that's going to be our number, about 2.5. We have running our own power and ground from the battery. We got the scope set up. I just am going to take an amperage measurement of this blower real quick. We're gonna do a quick touch. We should be okay since we do actually have resistance. I'm not really worried about shorting anything out and smoking the wires, but we'll do a quick touch and then we'll look at the current ramp trace on the scope. All right, we got it. Well, we had her rigged up about as best as we gonna get. Come on, struggle busting over here. And we'll just give it a quick touch. She does spin. What does that look like? Looks like we're pulling about 30 amps. So I was looking for a vertical here, and I think this is either going to be the brushes moving around, I assume, or I didn't make a great connection right off the bat. I'll try this one more time and see if I can get a better connection on the connection, so we can a better connection on the connection. That's what we're after. A better connection on the connection. I want to be able to see a longer ramp. It did spin. Here we go. Okay. That time she ran. She sounds pretty good. I don't hear any weird noises. All right. So I do believe, bring this in. Right here on this little ramp here, this is going to be our inrush of current, and then I'm going to say here's probably where the blower started to turn, and we've got our pintle hump, for lack of better words. Though, I don't know. I guess I really don't I don't take amperage measurements on blowers a whole lot, especially something that's not pulse width modulated anymore. I don't think that looks too vertical to me. It is a little vertical. I guess that could just be, going through the brush and then getting current ramped up. So, in any case, I do think that the blower is working the way it's supposed to, and she is operating off of 12 volts for sure. She sounds healthy. And then we can see, the rest of this. I suppose the next thing is going to be to move backwards through the wiring and figure out if she actually does have that 24 volts going to her, or if she's got something else showing up. Based on just connecting polarity of positive and negative and figuring out, you can kind of see it, there's a vent right here, and feeling the air blow out versus suck in. I determined this side should be connected to positive, this side should be connected to negative. Now let's move to the wire harness side. All right, we have done some correct calculations, maybe a little bit of assumptions and some testing. This one here should be negative, and then this one here should be positive. So I'm going to hang the negative through this little deal just to hold it separate. And I don't know if this thing grounds it or powers it, but we're going to find out. I'm going to take a test light, get my test light. We're going to connect one side of the test light to our jumped in battery power connections and see if we actually have power and or ground. Really, I'm going to test ground first, which means this needs to go to positive, and see if we have ground through that thing. And so now you can kind of see, I'm going to turn this. So the test light right now is looking for ground. So here's it looks like a ground eyelet over here on the right. Let's touch it, and it does light up. So we're looking for ground. And then we want to know, does this have ground? It does not have ground. Okay, so is this ground side switched, or is this part of our problem? We don't know. Let's go ahead and key her on. Actually, I'm going to get a battery charger hooked up to this, and then we'll key it on. Okie doke, key is on. Battery's hooked up, our battery charger. We're still looking for ground. Let's come in here. And we still do not have ground. The blower switch is in the off position. Let me walk over. I'm going to hit the, what I assume is the blower switch. Oh, that's weird. I did not expect this. Oh, because I don't know anything about these. This is not detented. This is like a freaking rheostat or something. That is fascinating. Well, I'm just going to move it, like it's smooth all the way across. All right. I'm just going to leave it right there in the middle for this test. There we go again. We're looking for ground. When we find ground, we light our test light. When we come up here to what should be ground, we still have no ground. I'm just going to check this other one just to make sure. And we have no ground there either. All right. I was not expecting that. Let me switch the fan to high. The fan is on high now. We're still looking for ground. So do we have ground? We have no ground. Do we have ground? We have no ground. Why don't we have any ground? Weird. Well, let's move the fan back to medium. I'm going to switch my test light to now look for power. Now when we find power, we should light it. Let's go to the power wire. We do have bright power. We have nothing there. Okay. What voltage do we have there? I don't know. Let us find out. And since we don't have a ground there, I was planning to run the scope to that ground. That's obviously not going to work. I'm going to connect the scope over here to our known good ground eyelet. It's about as good as you're going to get, and I'm probably going to be in the way. All right, we are set on medium for the blower. And when we plug in here, what do we have? Oh, that's ground. We have nothing. That's why. Holy smokes! Spoiler alert, what you just watched was actually a result of me having an intermittent short in the red scope lead itself. I actually discovered this particular intermittent short on another vehicle, and I'll just give you that quick rundown. Battery, fuel injectors, fuel injector control. On this other vehicle, I had run my red scope lead to the ground side of the injector and didn't have anything there. I then moved to the positive side of the injector and I blew this injector fuse here. Once I blew that injector fuse, I was like, oh, hey, something is going on with my setup. In the video that you're going to watch, I thought it was something to do with the scope itself, but it wasn't. It was the leads. And you'll hear me do some back and forth trying to figure it out. A little flustered, not thinking through the whole problem. But the leads actually had an intermittent short. Also, the lead issue is why we had so much noise in all of the other signals that you're going to be seeing. So if with that being just an intermittent short, it kept almost trying to take my voltage measurements to ground, which is a little terrifying. But that's what we got, and I can tell you, I won't be making that mistake again. Now, anytime we see some extra noise on a scope, I will be verifying that my leads are good. So that's what actually happened. Also, let me see if I can bring up this picture. Boom. Google says that if you use a capacitor, you can actually, depending on how you charge a capacitor, you can get like 1.5 to 2 times the input voltage for an output. And after talking with the company that you'll figure out later, they do use like some sort of charge capacitor to get that blower to start spinning. And really, the rest of this video is a little bit anticlimactic. We're going to continue to triage the issue as it were, but that was the sort of the fill in the blank spoiler alerts is for what you got for the rest of the video. Hope it's helpful for somebody out there. The company was super, super cool. I think I talk about it at the end of this video because I'm going back and editing in other stuff, but the company that makes this aftermarket install, super cool, super helpful, and yep, I'll let you get back to that video. Uh, well, I'm not really sure what to say at this moment. I went back and rewatched what you just watched a couple times, and I'm still processing, and I still don't know what happened. That is, that was odd. Let's show you what we got. Here's my lead. It melted the tip off. It melted this like plastic stuff. The this one it didn't do too much damage to, but melted the side like a little focus. Maybe it'll focus. You can kind of see it melted a little wire spot out of it where that lead was touching. That's minimal damage there. In my mind, I don't know what just happened. Maybe post-processing it'll all make sense. What did our voltage do? Well, our voltage went up to, that's a weird looking pattern. Let me turn this off. I don't know what I'm looking at. That's pretty bizarre. This is our pattern from the event. This spike right here is 20.22 volts. Now, where do we go next? Well, I have an idea because we first started with a test light and we did not catch the car on fire. At first I'm going to change this out to a better one and probably clean up my much desired AES wave connection. Clean those up. I think what we're going to have to do is go back to the test lot, plug the test lot in, and then take a voltage measurement, and hopefully we don't burn my goddamn scope up again. That's very odd. We should have, if that's the power side, we should be able to get a real voltage reading there without burning stuff up, because the test light worked. By the way, the test light was very bright. I don't know if you really noticed that. I didn't really catch it, but the test light is bright. Oh, hey. We do have a battery charger. So let me voice this live to you, and you can let me know in the comments what I did wrong. Split. We do have a battery charger hooked up, and I don't think that these drops here are going to be from the battery charger. If anything, I would expect these ripples at the top. It's a little ripply. Maybe I can blow it up so you can see it a little better. So this is a little ripply. I would expect that to be more battery charger stuff. Perhaps we need to take the battery charger off to do this next one. I think I'm still going to leave the battery charger on for the moment. I'm going to redo it with the test lot, touch the test lot to that circuit, and then touch the scope to it. And hopefully I didn't damage my scope. We will need to test that as well. We'll do that here once I get it cleaned up. All right, round 2. Let's see what we can burn down. We've switched to the yellow straight lead, which is statistically the least likely probe I am to use. And so if we do screw it up, hopefully it doesn't bother me too much. We are going to connect. I'm trying to connect over here on the side to ground. Let me see if I can get everything in the shot. Scope lead's on. This is coming in from our battery. We are going to let the scope reset. It just reset. I'm just going to touch here because I'm terrified. 2, touching, holding. Looks like we're sitting. There's a lot of noise on there, but there's a lot of noise. That's an obscene amount of noise. Why do we have so much noise there? Here's what we got. We're sitting in the middle of that noise at 13.7 volts. Let me turn off the battery charger. I want to do that check again. Battery charger is now off. Let us come back here. So now touching again. Holy cow, look at that noise. That is a bunch of noise. And our voltage in the middle of that noise is 13.2. The battery charger's off. Seriously? Battery charger's off. I'm going to take the connection off of the battery charger. Okay, I've removed the positive charging cable from the battery charger. Let's replay this again. Let's come up here. Touch. Man, still a bunch of noise at 13 volts. That's crazy. Oh, I'm curious about a couple. Okay, here's what we're going to do next. We're going to disconnect from our chassis ground. We're going to switch to our actual battery ground. So, actual battery ground, touch in. And it's still noisy. That is crazy. Okay. I'm going to continue on and do the test that I said we were going to do. I'm going to reconnect my scope ground over here to the bottom of the A-pillar. We've still got the key on. Our blower's in our mid position. The last time this did not catch anything on fire, so we're going to make sure you're in frame. This, I guess we got to connect our Gotta connect our test light to ground first on this end. So let's connect that up. So now the end of this is looking for power, and she's bright. She's not getting hot. Just kind of waiting here for a minute to see if this thing gets hot. Okay, it's bright and it's not getting hot. What then does our scope read? If I come in here, we're just touching it. Okay. Still nothing's getting hot. And we are, I'm getting a bad connection here, I think. Let's try it again. We're at battery voltage, and it's dropping out. I have a great connection here. Look at those dropouts. We are actually dropping voltage out of this thing, and we're still at 13 volts. She's coming down a little bit now. That is weird. That tells me what I think. Let's see. In theory, what I think I know at the moment, we got 20 volts going when we just use the scopes, and we have no load pulling the circuit down. It seems we have 20 volts on it. When we use just this, whatever it is, quarter amp test light or whatever, that's enough to pull the voltage down from 20 volts to about 12. It did come down just a little bit when we readjust. About 12.9 volts. So it pulls it down just enough to be in range there. That is interesting. I'm going to do the same test we just did, but I'm going to move the blower to high, and then I'm going to move the blower to low or off and see what results we get there. Blower is on high. We're going to take our test light. We're going to go back to positive. Make sure we're not smoking this thing. We are not. Nothing's getting hot. Touch briefly. Same result on the scope. I know it's out of glare, but you can kind of see that dashed horizontal line is 12.9 volts. We're getting these weird dropouts, even if I make sure we have good connection. Now we got more noise. There's a lot of noise there. That is bizarre. That is super bizarre. We're going to do one more test. The noise that we got here is on channel A, which channel A just caught on fire. I'm going to swap the lead to channel B, run the same test on, and see if we get the same noise on the scope. I need to make sure the scope's not damaged. Hold on, we have moved the red lead to channel B on the actual scope. This is going to look for power. We should have power at our test light. Apparently my work light in here went out. So we got that. We're going to reset. We're going to change our scale to voltage because I had that set on current. So voltage, wire you on 1 volt, 20 volt scale, reset. Okay. Blower's on high, just touching quickly. Nothing's happening. We still have all that noise. I don't know if you can, you can see it through the glare, but there's still a whole bunch of noise on here, and I'm holding this thing on with my finger, and still quite a bit of noise. What is our voltage level? 12.9 volts. So we still got extra voltage coming in here. All right, well, that gives me, you're falling. Gives me a little bit more comfort to know that likely we did not hurt the scope, which is good for me because that would put me in a bad mood real quick. I got to think about where to go next with this, and I'll bring you back once I'm done thinking for a minute. The plot has thickened a little. We're not calling it quits yet, but we do have some A little bit of differences. If you remember, I should have said that the vehicle harness side wires coming to the blower motor, the colors were orange and black. I'm going to show you that because they're not orange and black on the other side, nor are they thick gauge wires, which is a little weird. I don't know if I'll be able to get you up in there. Oh, we're going to try. Oh, that's the, you're looking at me. All right, this is vehicle harness side. And, of course, my fat hand's in the way. Disastrous. Can I just push it? Okay, orange and black. And they go right there. Like there's this weird sticky stuff. Let's see if I can get the white. There's that weird looking sticky stuff in there, and they go inside that weird sticky stuff looking insulation harness something. So there's only like 2 or 3 inches to work with. Oh, back when dashes are metal, we can magnet the light to it. Like it goes right there. As I pull on it, it goes inside this thing, whatever it is. Now let's go to the other side. Over here on the driver's side, we've got a pretty good rat's nest. And I mean, like it's, how do I get this to you? So, we have that. We have a really good rat's nest. None of that wiring is original. Yeah, in any case, this is actually a kind of cool design. It looks like a modern switchover for this blower. It's a cool concept. Obviously, we got some issue with it. But if I roll under here somehow, where we can see everything, which is not easy. I got a big glare on my screen. This big clear tube thing, where's my finger at? This big clear tube thing here seems to be a variable resistor, rheostat, whatever. And if you look, my finger at right there in the background, there's that little linkage looking deal. And as you move these knobs, you can see it moving. It pulls a rod in and out of that rheostat. This one is, the one I'm moving now is for like phase feet vent, I think. Or is it temperature? Oh, it's cold and hot. So I was moving the one there at the bottom. And then fan and face floor dash are even higher up. There's 2 more up there. Can I get the camera in here? This is really tough, by the way. Okay, now I'm going to move the face or the blower only, and you can see there's that one rod that's moving up top. So that's the blower. Now I'm going to do face dash whatever. That's this one. You can see it move. This is how it works. So, face dash feet whatever. But when I look at the blower one, which is the one on top that you can't hardly see, or you can kind of see it moving in the background, the wires that go to it, right there, if you look at this picture, I can't point, there's those 2 black wire harnesses coming up to the right diagonally out of this frame. And there's 3 wires, I think 3 wires in each of those. And those wires are very skinny gauge. And they are not black and orange. They're like red, black, and something else. But very, very small wires. I'm going to try to access that and see where it goes. Here's what I found. So specifically the blower rheostat deal, it has a red, a white, and a white with a green tracer. And where did I do with that? There are 4 individually wrapped wire harnesses that go into this one heat shrink. One of these 4 is for the blower. And then they all go into one, and then they all go into one. So I'm going to say this is our aftermarket, retro kit to make this thing work. But this piece goes, it's buried up under the dash. And if you remember our random purple wire from earlier, so what I'm doing here, I know this camera's all over, you just got to bear with me. I'm just kind of tugging on this a little bit. as I tug, that green or that purple wire and that floor vent are moving. I'm gonna go over there one more time and see if I can't find this. All right, it looks like I did find it where it comes over here on the passenger side. It looks like it goes into what I'm going to assume is some new fancy blower motor resistor. I don't know, but all of the, I'm going to call the skinny wires from the driver's side, they go into a connector and they plug into a box. Next to that connector is another box and it's got heavy gauge wire coming out of it. I'm going to try to get the phone up here so you can see what I see there in the background. There's, if you look at it would be the left, starting from the inside, it looks like blue, white, red, like white something, and white with a yellow tracer. And then on the right, starting from the right side, we got red, yellow, white, brown, purple, orange. The connector on the right is thick gauge wire. The connector on the left is skinny gauge wire. And the skinny gauge wire, there we go. The skinny gauge wire is from the driver's side, and so I assume, yeah, the heavy gauge wire is going to be some sort of blower control. I don't know. Even in looking just right now at the connector, the blower motor connector body harness side, the wires still look thicker than what they do coming out of this thing, and so I don't 100% know if that's still it or not. I'm going to see if I can't follow that wire coming out of the thicker gauge wire out of that harness block, whatever. Based on what I can see, where the little bit fatter wires come out, I followed that around, and that seems to go to the initial little black harness. I'll flip. They seem to come out here actually, and these don't go to the blower motor, but I can see an extra, like up here, there's an extra 2 fat wires that I think might be going to the motor wiring. But if we look at this dash piece, and I'll flip it around, if we look at this dash piece, it looks like it's mostly one big piece that I need to get access to. Those wires are, I'll try to zoom out, those wires are about right behind here. Huge shout out to Danchuk USA. I believe it is a company. They do old resto stuffs. They have a video on how to get this dude out without taking the entire dash out, which is awesome. There are 2 screws and 2 nuts that hold that thing in. Let me catch you up a little bit. The back of this thing has a stud and a stud. The front of this thing have 2 little screw holes at the top. Oops, I get that thing out, and it mounts the studs through there and the screw holes up through there. Once we pull that thing out, we can see there's this part number module thing for a, vintage air product. So now that we have somewhere to go with this, I've never heard of this company, and there's lots of wires that run back there. There's actually, that module we just saw is a full module. There's another module in the back of it that has more wires that go to it, and that module in the back of it is what has the blower motor wires coming out of it. Let me see if I can show you. Over on the right-hand side, coming over that black stuff, you can see there's an orange and a black wire. Those orange and black wire, previously when we were looking under, I thought went inside that black stuff, but they go over top of it. And they actually go, how do I show this? There. If you look at where there's a white and red wire, they dart to the left and they dart into what looks like another box. So this back here that I'm touching, or pointing at rather, that one there, That is another control module that controls the blower speeds. I then was like, hey, we have numbers to search. Search the numbers. It brought me to a company called Vintage Air. You can buy their products online from the race sites, Summit, Jegs, whatever else. Called their support line, got a sales guy who pointed me to a wiring diagram. And that's what I'm going to show you now. After we spoke a little bit, he transferred me to tech support, told him what experience we had with it, and I left him a message, and the tech support's going to call me back. But the sales guy is the one that gave me this link, and it's a little helpful. Here we have our whole standalone unit. By the way, I know I'm filming a screen here. Let me, whatever. It's a company. There we go. Vintage Air. Whoops. Vintage Air. If I go to products, whatever, ignore that. We're just going to switch back to this. It's a company that sells the whole HVAC box is a bolt-in unit. And this is our wiring that we got. What I'm going to draw your attention to specifically on this diagram is here's our blower motor. Here is our blower motor connector, which we found, and that blower motor connector then goes into this little box. That little box is called a BSC, Bravo Sierra Charlie box, it looks like, and then wires go everywhere else. Also, this drawn out or darker colored gray box has this indication up here. It says pre-wired. So everything inside this box is supposed to be set up coming from them, including the actual blower motor. With that, I'm going to wait for a phone call back from these folks and see if we can figure out why there's no ground, why we have 20 volts with the scope measured when it caught on fire, and why we have 12.9 volts with the test light or some sort of load plugged in to the device. Why does it bring it down? I'm suspecting that this module has failed. I still don't know if there's a transformer in there or not, but I'm still leaning to we didn't burn up the scope wires, like the actual leads that go back to the actual scope itself. We didn't damage the scope. That tells me there's no current flow through the scope. And so that current flow had to have been limited to just the tip of my test lead. And I think there's some sort of AC voltage there. I don't know how to explain it. I don't know. But it does look like, especially because when we look at the blower motor wires, they both go to that little sub black box deal. There's no ground, and with the higher voltage, I think we've got a module failure on this aftermarket kit that is causing our issue. Likewise, this is also super helpful. There's no power to the AC compressor, and this does show us AC compressor wiring as well. So that's awesome. Assuming it was done mostly correctly, I don't think that we're going to have to reverse engineer the AC compressor wiring if we get past this blower motor issue. Hopefully it's wired in correctly and we can just follow these wires through, and it's super, super helpful. That's what I got. We're waiting on a phone call back from tech support. Still waiting to review this data with the customer. I'll bring it back when I know more, and hopefully we can figure out what my scope caught on fire. All right, several days have actually passed since since I filmed the last scene, and I don't exactly remember where I left off, but I'm going to catch you up. And I did a couple other testings on the car that I 100% totally forgot to film, but they weren't anything mind-blowing, so I'm going to catch you up. I think we found the wiring diagram before, and so we've got the wiring diagram for this. I emailed Vintage Air with a couple of the issues that I was having, and apparently, so far I'll tell you this, if you ever deal with them, they're not prone to having tech support over the phone for whatever reason. I guess I could see that from their side. They might be less productive, but so we're limited to more or less email troubleshooting and guidance from those folks. That said, their emails are actually pretty helpful. I've been impressed and satisfied with the level of support I'm getting through email. But here is some info that I got from them. I asked, going through an email, and then I'll switch you to the wiring diagram just to get you a quick caught up. They did confirm on the blower circuit, it is ground side PWM controlled. So that mystery box does pulse the ground to control blower speed. And we still don't know why we have 20 volts being sent to that under, no load conditions, at least at the moment. And then they said we need to check the 2 ground wires to that box. Apparently there's a couple ground wires, which are in the wiring diagram. Verified those do have good ground. They wanted me to verify. Okay, then they said go to the 16-pin terminal, and we should have 12 volts on a red wire and 12 volts on a violet wire. In the wiring diagram, the red wire that goes to that mystery box is a constant power. We do have constant power there. And then there's a violet wire, which is supposed to get power when the key is on. We did not have key power on the violet wire, and I think I got it in the video. If you recall, there was a violet wire hanging behind the dash and run down to the carpet, just drooping. That was the violet wire for the key fed circuit, and it was not connected to anything. When we run to the key or our own power, it does power up the rest of the box. And as soon as I touch that key fed wire to power to simulate key on, the engine fan would start to run. And so what we have more or less discovered, I'll get to that. They said check a 5-volt wire and another ground on the connector next to, so that one mystery box has 2 connectors on it, and they wanted me to check power and grounds on one side, 12-volt powers on one side, and then also 5-volt and grounds on the other connector as well. And we had all that. Once we fed our power to our key fed wire, all of those were taken care of. Now, back to the actual thing that got a little weird. As soon as we hook up power to the key fed wire, we got the engine fan running all the time. But when we had power to the key fed wire, the dial, the mechanical switch for the blower control on the dash did operate the blower in a PWM fashion. So if I move that dial to the left, where the off position is, it would run the blower on low speed. If I move that dial to the right, it would run the blower on high speed. So the PWM control is working. There's apparently a calibration procedure to learn the blower speed off position, and we still have to complete that. We are waiting on further approval to keep going on the vehicle before that happens. And then the engine fan was running all the time. And I will show you why. So now I'm going to get you swapped over to this wiring diagram. Okay, this is our main connector that we were missing one of our powers to, specifically this violet wire here, which is supposed to go to the key. We were missing power there because this was just disconnected. And we did have on our red wire, which is this one, which goes down to just straight power, that has power to it at all times. What I found is whenever we plug the violet wire in, it turns this box on. And when the box turns on, because the position is not calibrated for the dial for the blower speed control, when you turn it to the off position, it is having a low speed currently learned value, and so it operates the blower on low. Now, when the blower is operating, or rather, when this box decides that the blower should be operating, which it is all the time because of the mislearned calibration, it then trips this compressor relay, and this compressor relay output goes to the AC switch and then to the AC clutch. If you remember, if I said it, we are not having power to the AC clutch as well, so this is another issue. And what I found here is the AC system only has about 20 psi in it, so it's not enough to trip this switch. Now, what's not shown here, and what I will also draw, if I can get around this tripod, what I found was here at the AC clutch, there was another, or excuse me, the AC pressure switch, there was another tie-in to the fan relay. Fan relay control. That means anytime, because there's no learned calibration, anytime we get power to the violet wire, this thing thinks that you want the blower speed, and AC controls on all the time. So it activates this relay to activate what should be the compressor eventually, and it also will turn on the fan for the condenser operation. And so it seems like anytime we have the AC on, we want the fan to be on. But I didn't have wiring for this, and I think they sent that to me in email. But really, that's where we got. Found some of these controls, found out why we didn't have power there, because this switch is not being tripped because we have low refrigerant pressure. But let's get back. Right now, I just wanted to get a little caught up. I just totally forgot to bring y'all along for the other one. We got a customer showing up. So this is what I got. Once we get further approval, we'll keep going on her. Let's get you caught up. Really, the stuff that I did now to wrap this thing up wasn't exciting at all. There's no triage. There's just following directions. I can show you on the directions what we got here. It's really not the directions I meant, but the diagram we followed the directions. This is our connector we've been dealing with. And there's this gray wire that comes off and wraps around, and it's called program. That was one of the wires that was just hanging down under here. I tucked it up behind the dash now. The instructions are, with the programming wire, what you want to do is turn, what exactly was it? Oh, you turn the blower on high, so you turn the key on, you turn the blower on high, you go to defrost position, and you move these all the way down. So they're just like that. Then all you do, this program wire that's just hanging out, you just ground it. So I grounded it to that little ground strap laying under there. Once you ground it for about 5 seconds, the blower speed will change, indicating that, hey, it detects it's in learn mode. And then once the blower speed changes, you come back to your dials, move those both to the left, move these both up, and then the blower speed will change again, indicating the calibration is done. That's it. That's all we did. Now it actually works. And the only other thing I did, which is not very eventful, that purple wire that was dangling here that we knew went to the box for ignition, I put a little end piece on it because it wasn't long enough, and we ran it up to the old school ignition switch there. Now, when we key on, we have nothing going on. The GPS up there makes some beepies. And now, if we turn this on, two things happen. I'll show you that first before it gets loud. The blower comes on through the vents that you want, and power is sent out to Power is sent out to our low pressure switch for the AC system. I do have pressure in it right now, doing a leak check because I found a leak actually. It was low on refrigerant. There, again, nothing exciting there. There was an O-ring here that was leaking. I just sprayed it with soapy water and it was bubbling. And then that line goes right down here. And you kind of got to take both ends off to actually fit the O-rings in them. So I put a new O-ring there, only because I had to take that side off in order to put a new O-ring here. And now we've just got pressure in the system, but I'm not going to turn it on This trigger wire here will also come from, so this comes from the AC control module, and then when there's pressure in the switch, it runs to this wire, and that just goes to the clutch, and then this green wire has been wired in. That just triggers the fan. So anytime we have the AC request on, it goes through this very complex fan relay that has like 2 fan controls, an AC control, and a coolant temperature control, like all feeding this thing, and it'll turn the electric fan on for any of those requests. So I'm just going to show you, I can do all this now with a key in the on position. We ain't got to run the thing. So key is on. I'm going to turn this a little bit. I don't know if you can hear it, but air is blowing out of this vent. I also don't know if you could hear it, but the AC clutch kicked in and the fan is now running. What I'm going to do is turn this off. We'll let the fan shut off, and I'm going to try to do all this in one shot so you can see how it works. It's actually a pretty cool little setup. What I'm going to do is reach in here in the dash. I don't know if you can see my hand. And I'm just going to flip the blower on, and then we're going to go run and look at the AC clutch real quick. So it's on, and then boom, the fan's running. Turn that off. So it seems that's it. AC clutch comes on, fan request comes on based on the switch they got there, and that seems to actually have fixed the issue. Right now, again, I'm just leak checking the system, make sure it's not going to actually leak when I do put refrigerant in it. I still don't know why my scope melted down. I did not get that response from Vintage Air very clearly. The response I did get on the specific question I got didn't really match the findings we had, so I'm not sure anybody knows. But regardless, if we got a 12-volt battery and we got 20 volts coming out of that thing, there's a transformer in there, like, or some sort of even a capacitor. I don't know if capacitors can be charged by 12 volts and discharged more than 12 volts. I don't think they can. I never learned that they could. If they can, somebody let me know in the comments. Other than that, I don't know why my scope burned down, but she's pretty well fixed. That's what we got. I hope this is helpful for someone out there. You run into a Vintage Air problem on your 1955 Chevrolet 150 ONE-FIFTY, slightly modified. I'll catch y'all up in the next video.